All right, number 15 and 16 are referring to this lovely chart here. And so number 15 says, use notation independent and dependent to characterize the function in this chart. Okay, so in other words, read the descriptors of the chart and tell me what variables we're measuring here and what would be what. So in this case, our independent variable, which is right there, would be on our x-axis, and our dependent variable would be on our y-axis. So we are saying the independent is maintenance and our dependent would be repair. Okay. Number 16 asks us to describe the domain and range of this function. So we're going to set up a set of numbers, so it's the variable x such that, then we're going to look at our x-axis, and our x-axis seems to go from around, let's say 2500 all the way up to 2800. So the domain is anything between those two values. So 2500 less than or equal to x less than or equal to 2800. Our range, again, what we consider our y values, and it looks like, I can tell that it goes below 600. It's somewhat above 5, so we're going to say between 5 and 7. Maybe cover our bases because one of those points is a little bit higher, so we'll go a little bit above 700, maybe 725. So our range is anything between 500 and 725. Now notice I intentionally left off a symbol, so on my range I have it less than and then less than or equal to. I clearly see that 500 is a lower bound. I can't quite tell if it's 550 or 575, so I'm just going to say that clearly 500 is the smaller end and 725 is the upper end, and it might even equal up to 725, but since I don't see that specific number, I can't quite tell. Alright, number 17 to 22, we're going to refer to this graph. So in this graph, let's see, I'm going to read some questions here. What is the concentration at day 9? Well, day 9 is halfway between 8 and 10, so right there, which means it's halfway between 4 and 5, so 4.5 parts per million. What is the rate of change? Okay, rate of change, I'm going to look for a couple of good points. So I see a point here, crosses a grid line. There's another point, crosses a grid line. There's another one. And so I'm going to go up 1 and over, I want to say 3, up 1 and over 3, but if you look on the x-axis, we didn't really count by 3s, we counted by 2s. So we went up 1 and over 6, and that would be days per parts per million. Number 19, by how much does the concentration rise over the space of 6 days? So we kind of looked at that. Every 6 days it goes up 1, so 1 part per million. What is the initial value of the concentration? So right where does it cross the y-axis? So that would be 3 parts per million. Write an equation consisting of concentration as a function of time. So think y equals mx plus b, only we're not using y's and x's, we're using c's and t's. And we've actually figured out what our numbers are for our slope and our y-intercept already. So in this case, the concentration would be 1/6 times time plus 3. And then lastly is use our equation to make a prediction on day 19. So the concentration would be 1/6 times 19 plus 3. And if I type that in a calculator, I get about 6.16 parts per million. All right, number 23, your starting salary at your new job is $32,000, and you've heard that employees generally get a 5% raise per year. At that rate, what will your salary be in 4 years? Okay, so we want to set up our exponential growth formula. So our initial amount, 32,000 times 1 plus, and we get a 5% raise once a year, and that's for 4 years. So we should be 38,896.20. Now, if you're calculator challenged, that would be 3,200 times 1 plus 0.05 divided by 1 caret parentheses 1 times 4. Should give you that same value. Number 24, Peter placed $500 in a brokerage account that's been increasing its value at 14% per year. At the same time, Paul began placing $500 under a mattress at the beginning of each year. Who had more money after 15 years and by how much? Okay, so each of them sort of did a different approach. Now Peter just stuck money in an account and just let it sit there. So that's going to be 500 times 1 plus 0.14 over 1 times 15 for the exponent, and we should get 3,568.97. Paul, on the other hand, just kept every year he'd place more money under his mattress. So we put $500 each year, so 500 times 15 is 7,500. Now, if Paul added money to his account, he'd actually make more money in the end, but that's not what it said in this question. So the last part is who made more and how much. So Paul made more, and if I subtract those two numbers, he made $3,931.03 more. Number 25, the average price of a home in a certain town was $74,000 in 2008, but home prices have been falling by 8% per year. Create an exponential function of the form Q equals Q naught 1 plus R, and it's sort of a typo there. I'm going to worry about that on the test. Hopefully it showed up correctly, where it's an exponent of t. Let's see, so in this case, we're going to say our amount is 7,400, 1 minus, because we're falling, 0.08 raised to the t, or 7,400 times 0.92 to the t, would tell me how much money the home is worth in a given amount of time. So Q in this case is the amount house is worth. T would be time in years. 26, suppose that poaching reduces the population of an endangered animal by 9% per year. Further, suppose that when the population of this animal falls below 15, its extinction is inevitable, owing to the lack of reproductive options without severe inbreeding. If the current population of this animal is 1,800, in how many years will it face extinction? Okay, so let's kind of set this up, and then we'll talk about some techniques that we can look at as far as solving it goes. So what we're told is, I want to know how long till the population reaches 15, given that it decreases by 9% each year. Okay, so simplify that up again, 0.91t. All right, now at this point, how you go about answering this sort of depends on your calculator skills. If you remember a little bit from algebra in high school, or even college algebra from college, and that's okay. You've got some exponent rules you can manipulate. I'm actually going to use Excel to answer this question, so let me go pull that up. Okay, so what I'm going to do here is I'm going to set this up as 1800 times 0.91 caret, and then I'm going to click on a cell here, which right now is nothing in it. So let me see if I put a number in here, if that updates it. Okay, so it did in fact update it. Okay, so what I want to know is how many years does it take before it finally reaches 15. So I'm just going to start guessing numbers at this point. So start with 10. Notice it's decreasing. It's kind of that high-low game. You just keep playing around with the numbers. And after I do this using Excel, I'll come back and show you using exponent rules another way we could go about doing this. So it looks like 50's close, 60's too small. Let's go 55. So we're trying to get 15 out of this. 55 is too big. Let's go 53, 52, 51. Okay, so it's between 50 and 51. How about 50.5? Okay, 50.5 is too big. Let's do 50.1. Oh, that's too big. We want it smaller. So that means we want to go up. Okay, so 50.7. But actually type what I wrote. 50.7. Getting closer. 50.8. Okay, so it's be 50.8 and 50.7. So let's split the difference. 50.75. Okay, so 50.75 is pretty good. All right, so we'll go with that 50.75. So let me go back to our problem, and then I'll show you another way you can solve the same question. Okay, so using Excel, we got 50.75. Now, we can go do this another way. So we got 15 equals 1800.91 to the t. So if you remember from exponent rules, if I take the natural log of both sides, so natural log of 15, that allows me to bring down, I'm sorry, let me try that again. I need to isolate out the variable first. So I want 15 divided by 1800 equals 0.91 to the t. Now I want to take the natural log. So ln of 15 over 1800 equals t times the ln of 0.91. And then I want to divide. So ln of 15 over 1800 equals ln of 0.91. And if I type that in a calculator, let's see. Let me see what we get. Should be pretty close to what we just came up with in Excel. Okay, we actually get 50.763 with some decimal accuracy, so not bad. So if you feel okay with exponent rules, then you're more than welcome to use that method. If you're okay with Excel, then of course you got the Excel method that I just showed you. All right, lastly, number 27, a toxic radioactive substance in the amount of 8 milligrams per square centimeter is detected in the ventilating ducts of an old nuclear processing building. If the half-life 13 years, what was the amount of the substance when it was deposited 56 years ago? Okay, so using our half-life formula, we have that it's 8 milligrams now. I don't know what the initial amount was, so 1/2 56 over 13. So I just want to solve that. So I want to take 8, divide that by 1/2 56 over 13, which, if you type that in correctly, should be 158.43 milligrams. Okay, now for calculator help, it would be 8 divided by parentheses 1 divided by 2 caret 56 over 13 close caret should give you 158.43.